Welcome to Are You Chemistry GCSE Ready? This playlist takes you through loads of example questions and guided solutions for every single topic in your chemistry GCSE. So it's a perfect way for you to test your chemistry knowledge. If you feel like you need a quick review or you just want the ideal revision companion for these videos, then make sure to download my free chemistry GCSE revision notes. I've linked them in the description below. Or if you're ready, let's dive straight in.
Okay, let's have a look at these electrolysis questions. So first here we have, what type of compounds are usually involved in electrolysis? And you need to remember that it's probably ionic compounds because the electrolytes need to contain ions that can move. Electrolytes, remember, is just that liquid where these ions are contained. What states must these compounds be in to be able to be electrolyzed? Well, they have to be either molten, brackets liquid, or aqueous, so dissolved in water. And the reason for that is that's when I get those ions being split up and free to move in my ionic compounds. What is oxidation and reduction, and where do they occur during electrolysis? So this is when we remember this mnemonic oil rig, and that stands for oxidation is loss and reduction is gain. Loss and gain of what? We are talking all about losing and gaining electrons here. Where do these two things occur? Then we've got this other helpful way of reminding us, red cat and an ox. Reduction happens at the cathode and oxidation happens at the anode. So let's just think about that for a second. If we're at the cathode, and another mnemonic here, panic, positive anode, negative is cathode. So we're at the cathode, we're at our negative electrode. What's going to be attracted there? It is our positive ions that are going to be attracted to that negative cathode. Okay. And then what you get is those positive ions, in order to be discharged, need to gain some electrons. So reduction is gain. At the cathode, you have reduction because those positive ions are gaining electrons. Whereas at the anode, okay, again, panic, positive anode. So our anode is the positive electrode, and therefore it's attracting the negative ions towards it. And in order for those to discharge, they lose their electrons at the anode. Oxidation is loss. So we have all of these different mnemonics and ways to help you remember it, but you can, as long as you know one or two of them, you can think through logically the process, and you should be able to deduce where reduction and oxidation would happen. How do we work out the products of molten electrolysis? Well, you can think of molten electrolysis as a little bit like a reverse reaction, in a sense that the products that you get from doing it are those elements that made up your ionic compound in the first place. So for example, if your compound was lead bromide, then the two products you would get from this molten electrolysis would be the lead and the bromine that were the elements in the first place that we used to make this compound of lead bromide. And it works like that because there are no other substances other than the lead and the bromine in lead bromide. However, if instead you had aqueous electrolysis, your ionic compound this time has been dissolved in water. So it's not as straightforward as those two elements that are in the compound, and we need to think things through a little bit further. And depending on if we're looking at the cations or anions, different things will happen. So let's think about the cations first. So the cations are those positive ions in your aqueous solution, and those are going to be in your ionic compounds, your metals. And if your cation is less reactive than hydrogen, then that metal will be produced. But if your cation is more reactive than hydrogen, then hydrogen will be produced instead. You might be asking, where's the hydrogen coming from? Well, the hydrogen, you can have those positive hydrogen ions coming from the water that you have dissolved this ionic compound in. For your anions, you have to think about whether you've got a halide or not. So your anions are your negative ions in this ionic compound, and your halides are the ions that come from group 7. So group 7 is where you have all your halogens. So for example, chlorine, and the halide for chlorine would be your chloride ions, which is a negative ion. And if you have a halide, your halogen will be produced. So the chlorine will have been produced. But if you don't have a halide, then the oxygen is produced from the hydroxide. And that hydroxide, again, is coming from this water that's also being involved in this aqueous electrolysis. How do we describe the products that we observe? So if you have a gas, you talk about the gas being effervescence that you see, bubbling or fizzing. If it's a solid, you talk about a solid layer forms. And if you know the colour, make sure to add that as well. So silver, for example, you would say grey solid layer formed. Okay, and just to add in some examples here of how we decide which products are made in our aqueous electrolysis. So work out the products of copper chloride and then sodium sulfate. So copper chloride first. So copper is going to be what produces my cations here, those positive ions. And now I have to decide, is copper more or less reactive than hydrogen? So copper is less reactive than hydrogen, which means that I'm going to get this copper being formed at that electrode. So I could say a solid layer forms of copper. Now, chloride here, that is a halide, and therefore I know that I get that halogen produced. So I get my chlorine gas being produced, and that's as opposed to some oxygen gas from the hydroxide. So then my second example, though, sodium sulfate. So again, sodium is my cation here, but it's higher in the reactivity series than hydrogen. So this time it's hydrogen that gets discharged here. And for my sulfate, well, my sulfate's a complex ion, it's not a halide, and therefore I get my oxygen gas being produced at my anode from the hydroxide. Half equations. Write a half equation to show oxide ions being discharged during electrolysis. So first things first, you have to start by writing your starting ion. So I know that my oxygen is in group 6, and therefore I have my ion as a -2 charge, as my oxygen is gaining 2 electrons to fill its outer shell. Next, I need to add the product being the oxygen that I get at the end, but I need to know that my oxygen is a diatomic molecule, and therefore it's not just going to be O, it's going to be O2, my product. So I've got my ion on the left-hand side, and then the product I'm expecting on my right-hand side. Now, I need to balance the atoms here. So 2 on the right at the minute from that O2, but there's only 1 on the left. So I need to put a 2 in front of my left-hand side. And now, finally, I need to balance the charge. And I do it by adding or taking away electrons, by adding some negative electrons to the side of my oxygen. Because at the minute, on my left-hand side, I've got 2 of these oxide ions, and they've got a charge of -2. So overall, I've got a charge of -4. And on my right-hand side, I've got a charge of 0. So I need to add 4 electrons to the right-hand side so that I add that 4 negative charges to my right-hand side, and then my left-hand side has the same charge as my right-hand side, and I'm all done here. Okay, what is a chemical cell and what is a fuel cell? So A chemical cell, we have a setup that allows a reaction between two elements to occur, and then you can harness the energy that is given off in that reaction and use it as electrical energy. And really, that's kind of like the opposite to electrolysis in a sense. In electrolysis, we had a compound, like an ionic compound. We put energy in, and then we get out the two different elements. But for a chemical cell, you have the elements and you get energy out by them forming to make these compounds. Um, you could stop producing a current or a voltage on this chemical cell once the reactants run out. So a fuel cell is a chemical cell, but we supply it with a fuel and oxygen, and you can quickly refuel it because you just need to add more fuel to your fuel cell in order to do that.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
Okay, some tips and tricks for this section. You need to know your diatomic elements. You'll miss loads of marks otherwise in your half equations because you will not have balanced your equations properly. You'll need to learn the reactivity series as well so that you can predict what happens at the cathode. Remember, for your aqueous electrolysis, you need to know if it's more or less reactive than, for example, hydrogen when it's dissolved in water. You can come up with your own mnemonic to do that. That'd be a great way of doing that, although it's a bit of a mnemonic overkill at this point with oil rig and panic and loads of other mnemonics as well. When adding electrons into half equations, remember all you can change is how many of them you add. The charge of an electron is always -1. So if, like our example for oxygen, you had a charge of -4 from your oxygen ions on the left-hand side, then you would have to add 4 electrons to your right-hand side so that you had that charge of -4.